Hello student, myself Dr. Chandramali Sharma, and in today's video I am going to discuss objective questions of stereochemistry and conformers. Let's start to the question number 1. Draw the structure of malic and fumaric acid, indicate kind of isomerism in it. As we all know that malic and fumaric acids are dicarboxylic acid having carbon-carbon double bond. To find out which kind of the isomerism they are showing, for that we'll have to see their structures. So your answer is the structure of malic and fumaric acid are just given on your screen. In this structure there are two COOH group, and these two COOH group are present on different carbon, and carbon carbon is having double bond. Due to this property, malic and fumaric acid are showing geometrical isomerism. There are two types of geometrical isomerism, cis and trans. So these two are showing cis and trans isomerism. Cis isomers are those isomers in which the same function group present on different carbon in same plane, while in trans isomer different functional groups present on different carbon in different plane. So from this explanation, we can easily say that malic acid is showing cis isomerism because COOH group are present in same plane, while fumaric acid is showing trans isomerism because COOH group are present on different plane. Question number 2. What is levorotatory? Before going on its definition, first we'll have to see how optical activity of organic substance determined. For this, we'll have to use polarimeter, and pictorial representation of polarimeter is given on your screen. In this figure, first of all, ordinary light is passing through polarimeter and it is converted into plane polarized light. And when this plane polarized light is passing through a sample tube, then the waves of light are migrated towards left hand side or right hand side. If waves are migrated towards left or right, then organic substances are said to be optically active, and that's why this is the given to you. When plane polarized light is passed through the liquid or dissolved state of substances, the plane of oscillation gets rotated through some angle towards left or right of the original plane of oscillations. The substance which rotate the plane of polarized light are called optically active substances. The substance which rotate plane polarized light in anti-clock direction, means towards left, are called levorotatory, while the substance which rotate the plane polarized light in clockwise direction, means towards right, are called dextrorotatory substance. This is indicated by putting letter L or negative sign before the name of substance if the isomer is LEVO. So your answer is the substance which rotate plane polarized light in the anti-clock direction, means towards left, are called levorotatory substance. Question number 3. How many stereoisomers are possible in 2,3-dihydroxybutane 1,4-dioic acid? Number of stereoisomers depends upon number of chiral carbon which is present in the molecule, and for finding out total number of stereoisomer we'll have to use Ventsoff rule, and Ventsoff rule also depends upon number of the chiral carbon present in the molecule. There are three rules of Ventsoff for finding out number of stereoisomers. We'll have to see how many stereoisomers are possible in 2,3-dihydroxybutane 1,4-dioic acid, which is commercially known as tartaric acid. For that, we'll have to study its structure. So the structure is given on your screen. From its structure, we can easily see that there are two chiral carbon present in tartaric acid. So when the molecule is asymmetrical, because it is having two chiral carbon and the number of chiral carbons are in even number, there are two chiral carbons. So according to Vent's rule, number of dextro and levo forms can be calculated by this equation 2 raised to n minus 1, and number of mesoform can be calculated by 2 raised to n by 2 minus 1, where n is equal to number of chiral carbon, that is 2, and total number of stereoisomers can be calculated by number of dextro and levo forms plus number of mesoforms. As I told you, tartaric acid having two chiral carbons, hence according to Vent's rule, which is given above, first of all find out the number of dextro and levo forms. So number of dextro and levo forms is equal to 2 raised to n minus 1, where n is equal to 2. So we'll get the value 2. Number of mesoforms can be calculated by 2 raised to n by 2 minus 1, where n is equal to 2. Put the value of n in this equation, you will get its value 1. So total number of stereoisomers are 2 plus 1, 3. There are 3 stereoisomers for tartaric acid, and these 3 isomers are given on your screen. First one is dextro, second one is the levo, and third one is mesomer. So your answer is tartaric acid is having 3 stereoisomers: dextro, levo, and mesomer. Next question is, what is 3O? Before going on its definition, first we'll see what is 3O and erythrio. Molecule with two different chiral centers are often designated by prefix 3O or erythrio, depending on whether similar groups are on the same side or on opposite side of the Fischer projection respectively. For example, two molecules are given on your screen. In first molecule, two Br groups are present on same sides. That's why it is erythrio according to explanation. And in second molecule, two Br groups are present on opposite side. So according to explanation, it is 3O. From this explanation, you can easily write the definition of 3O. Molecules with two similar groups on opposite side of carbon chain in that Fischer projection are termed as 3O. Our next question is, what is chirality? Before going on the definition, one example is given on your screen. This is the lactic acid. In lactic acid, this carbon is chiral carbon because this carbon is having different four function groups surrounding it. That's why according to definition, this is chiral carbon and this is chiral center. So your answer is, if in organic molecule carbon is having different atoms or function group is known as chiral carbon, and its phenomenon is called the chirality, and this molecule is optically active. Next question is, what is conformers? It is very easy question, so we can directly write the definition. Different non-identical arrangement of atoms or group in a molecule that result by rotation about a single bond and that can easily reconverted at room temperature are known as conformers. One example is given on your screen. This is the two conformers, eclipsed and staggered. This eclipsed and staggered conformers are converted into each other. So this is the example of conformers. Question is what is enantiomer? Give one example of it. Before going on the enantiomers, just we look up the brief explanation. Enantiomers are molecules which are mirror image of each other, means they should not be non-superimposed. They should be non-superimposed. One figure is given on your screen. This is the chiral carbon because it is having the different four atoms A, B, C, D. And right hand side is the mirror image of left hand side. If you cut this molecule and just put it over on this molecule, then you will observe that this is non-superimposed on each other, hence they are enantiomers. So definition is now become easy. Compounds which are mirror image of each other and are not superimposable are termed as enantiomers. For example, two examples are given on your screen. First is 2-butanol. These two are non-superimposed on each other, and second example is lactic acid. This also non-superimposed on each other. Next question is how many stereoisomer is present in 2,3-dibromobutane? To calculate number of stereoisomer, we'll have to see number of chiral carbon. This thing we have already discussed in previous question. The structure of 2,3-dibromobutane is just given on your screen. From this structure, we can say that there are two chiral carbons, and we'll have to apply Ventsoff rule. According to the rule, number of dextro and levo forms can be calculated by 2 raised to n minus 1, and number of mesoform can be calculated by 2 raised to n by 2 minus 1, where n is equal to 2 because the molecule is having two chiral carbon. And total number of stereoisomers can be calculated by number of dextro and levo forms plus number of mesoforms. As I told you, 2,3-dibromobutane is having two chiral carbon. Hence, according to Ventsoff rule, number of dextro and levo form is equal to 2 raised to n minus 1. Just put the value n is equal to 2, so we'll get its value 2. And number of mesoform is equal to 2 raised to n by 2 minus 1. Put the value of n is equal to 2, you will get its value 1. So total number of stereoisomers are 2 plus 1 is equal to 3, and this 3 isomer is just given on your screen. First one is mesomer, second one is dextro, and third one is levo. So your answer is total number of stereoisomers is 3. Next question, what is optical isomerism? Give one example of it. It is very easy question, so we'll directly go on its definition. Isomers are molecules that have the same molecular formula but have different arrangement of atom in the space. If the arrangement in the space make two isomer non-superimposable mirror image of each other, then it is known as optical isomers, and the phenomenon is found the optical isomerism. For optical isomerism, one chiral carbon should be present in molecule. Then and then they can show optical isomerism. Two examples are given on your screen. First one is 2-butanol. This is having one optically active carbon, and these two are mirror image of each other. And second example is lactic acid. It is also is having one chiral carbon, and these two are mirror image of each other, and these two are non-superimposed on each other. So these are the important questions which may ask in your exam in objective portion.